Okay, this is question number 5, and we have a berry. It's a small fruit. We have the mass of the berry, so 0.025 is the same as 1 on 40, initially at rest, then it falls from a tree. So the berry is here, and it's d units away from a wall, and it falls vertically x meters, then it slides down this slant. First thing I can think of, because the triangle is a 3 and a 5, then Pythagoras' theorem tells me that that's 4. So of the angle theta that I've marked, the sine of theta is 3/5 and the cos of theta is 4/5. This is 3 meters. Okay, so I've got that information. Find the distance in meters that the berry falls when it hits the plank. Okay, so when it falls, it's just a berry that's not connected to anything. So it's got acceleration of -9.8, and I've got this information. It takes half a second to fall. That information's been given to me here. At 0.5, the berry hits the plank. So it's got half a second. U is 0 because it was stationary when it starts to fall. A is that, so I've used this rule, my distance rule, sub it in, and that tells me the distance of x. What speed in meters per second? So I'm going to use v squared equals u squared plus 2as, because I know the initial velocity was 0. A I know, because it's -9.8, and s I know, because I've just worked out how far s is, and that tells me the velocity when it hits the plank, 4.9 meters per second. Show the magnitude of the component of the velocity of the berry in the direction along the plank at the instant is 2.94. So this 4.9 meters per second, which is down, gets broken into a component in the direction of the plank. So I've got a triangle there, and I've broken this vector into one along the plank and one perpendicular, and the one along the plank will be 4.9 times the sine of theta, and I know the sine of theta is 3/5, therefore 2.94. Over the page, the berry does not bounce or deform, but immediately slides down the plank with an initial speed of 2.94, the answer that we just got. Subject to gravity and a constant resistance magnitude r, that is opposed to the direction of motion. So there is my r going up the plank. There is my n, which is perpendicular to the plank. And here is my weight force that I've broken into two separate forces. So down the plank we have the resultant force equals g40 sine theta, that's this force here going down the plank, minus r. My mass is 1/40th, my acceleration because I know that my velocity went from 2.94 down to 1.06 after 2 seconds, I've used this rule to find out my acceleration. And then I've put that in here. And I've solved for r, and this is going to be my r value. And d, find the horizontal distance d that the wall, from the wall to the initial position. So what's d? That's d there. So what have I done? I've used how far totally did it slide down, and it slid down 4. So this bit is 4, the berry lands here. So the distance from here to the edge is 4. I know the total distance is 5. I know this bit here is 3. So I can use x using this triangle, and I know that that's 4, so I end up with 0.08.